Alpha Houston on space to ground 1 for Don. We're ready for your downlink.
Okay, I'm going to hit play.
I'm Don Pettit. I was fortunate enough to be science officer on Expedition 6 to the International Space Station. And during this expedition, we had several kinds of science that we did. We did programmatic science, which is well-planned and well-thought-out science, comes up from the ground and is orchestrated from the ground. And then we have science of opportunity. And this is science that is done at the discretion of the scientists on board space station. And this is kind of the discovery science. And during our mission, we called our science of opportunity Saturday morning science. Now we're going to look at spheres about 25 millimeters in diameter that are free floating spheres that are rotating. And they're filled with bubbles. And we're going to look at the fate of the bubbles in this rotating sphere. So let's go ahead and take a peek.
And what I've done here is take a syringe with a Teflon cannula, and I've squirted out a little bit of water, which has a whole bunch of bubbles suspended within the water, and some of our no-rinse shampoo. And what I'm going to do here with the cannula is I'm going to try to get this blob of water to rotate. And here I'm rotating the blob of water using the cannula as a little stick to hit it with.
Here we've got this sphere. Again, it's about 25 millimeters, maybe an inch in diameter, and it's rotating slowly. And look what happens as a function of time.
You can see that that cloud of bubbles are all starting to move towards the axis of rotation due to the angular acceleration created by rotation. It puts forces on the bubbles not unlike gravitational forces, and it makes them move to the center.
And we can see different stages of development here, and ultimately nearly all the bubbles end up in this rather well-defined core. It almost looks like a little white tornado inside of this rotating sphere. Here we have, again, a rotating sphere with bubbles, but there also has been introduced some tea leaves. So now you can see that the tea leaves are denser than the water, and the rotating motion causes the tea leaves to go to the outside of the sphere, while the bubbles are all driven into the center to form a core. And again, this is all freshman level physics, so everybody should understand what they see here. Here we have another free rotating sphere, and it has bubbles in it, forming a bubble core, but it also has little solid chunks taken from a vitamin tablet that I broke up. And it turns out these chunks of vitamin don't behave like the tea leaves, where we saw the tea leaves went to the outside edge. These chunks of vitamin tablet just stay floating, stay suspended in the droplet. They don't seem to move either to the outside edge or to the center. So from that, I conclude that the density of this pressed vitamin powder pellet, those little chunks have a density that is close to the density of the water, so that the acceleration motion, the acceleration forces from rotating motion won't make the vitamin tablets move either to the outside or move to the center.
That cloud of bubbles are all starting to move towards the axis of rotation due to the angular acceleration created by rotation. It puts forces on the bubbles, and it makes them move to the center.
So now you can see that the tea leaves are denser than the water, and the rotating motion causes the tea leaves to go to the outside of the sphere, while the bubbles are all driven into the center to form a core. Where we saw the tea leaves went to the outside edge, these chunks of vitamin tablet just stay floating, stay suspended in the droplet. They don't seem to move either to the outside edge or to the center.
And Houston Alpha, that's it for for our Saturday morning science.